Good morning. Good morning and welcome, Arvind sir.
जय काल महाकाल।
Yes, sir. So can I start?
Yes, sir. Sir, let me introduce something and then will you please allow me?
Yes, sir.
So, good morning and welcome, Arvind sir. On the behalf of the Department of Mathematics, Wilson College, Autonomous, Mumbai, I welcome you all in the today's session. So, our today's guest is Mr. Arvind Kumar Mishra, and he will deal with the topic of differential equations today. He is an assistant professor in the Department of Mathematics at Thadomal Shahani Engineering College at Bandra, Mumbai. His research interests are fractional calculus, complex variable, and integral transform. And fine. So please, it is for, all the students. Please change your Zoom username to your full name. Otherwise, your attendance won't be counted. Please do it if you are not done and then rejoin. Fine. Over to you, sir.
Yeah. Thank you. Thank you, sir. Students, I'm audible?
Yes,
Yes, sir,
Hello.
sir.
you are.
Yeah, yeah. So you are familiar with differential equation?
Yes, sir.
Yes, sir.
Yes. So can anyone define? Suppose I am here writing in one equation x plus y equals to 5. Can you make a differential equation here?
Yes, sir. By differentiating.
Sorry?
By differentiating this equation.
By
sir.
differentiating. So what we can say, please see here, we can say here y equals to 5 minus x. One can see if you make a table here x and y, you can consider any value of x that is minus infinity to plus infinity. Agreed? And we get the corresponding value of y. So we can say here y, the value of y depend upon value of x. Agreed? Means x is independent. We can independently choose the value of x and we can derive the value of y. So basically here y is known as dependent variable and x is independent variable. Agreed? Just you suggested that sir differentiate it so we can get the differential equation. So it can be written as dy by dx equals to 0 and minus 1. So dy by dx equals to minus 1. Agreed? Another thing you can take here, if you consider y equals to a times e raised to 2x plus b times e raised to minus 3x. So what will be the form of differential equation? What will
The
be form of
second order differential equation.
second order? How you have decided?
Because there are two unknown constants, sir, A and B.
Yeah, two unknowns. So order, one new thing is order. So means here if you consider dy by dx, so this is 2 times e raised to 2x plus, sorry, minus 3 times b e raised to minus 3x. Again differentiate it. So d2y by dx2 equals to 4 times a e raised to 2x plus 9 times e raised to minus 3x. On simplifying, we can get a second order differential equation d2y by dx2 plus 5x into y equals to 0. Agreed? So this is your order. Order means how many times you are differentiating. That number of differentiation is known as order. Next, if you consider here, yes. What about this? d2y by dx2 plus dy by dx the whole half square plus y equals to 0. Is it linear?
No,
No, sir.
sir.
No. Why?
Degree is not one.
Yeah, degree. So one new
Degree.
term is come, new terms come there, that is known as degree. So here order and degree, there are two things. So in our syllabus we have only linear differential equation, or we can say here ordinary differential equation, and here specification is first order and first degree, as well as higher order differential equation. So here first order and first degree we have already seen, that is one part is separation of variable, another thing is reducible to separation of variable form, another thing is homogeneous differential equation, reducible to homogeneous form, another thing is exact differential equation, and reducible to exact. Have you seen the paper, jam paper? Linear differential equation, reducible to linear, another thing is Bernoulli's differential equation. And here application of these things, there is, have you seen this orthogonal trajectory? Hello? What about orthogonal trajectory? This is the application of this differential equation. Agreed? Another thing, in paper people always used to ask about the problem based on integrating factors. Another thing, problem for Bernoulli's. Another thing we have, what is initial value problem? What is initial value problem? What is initial value problem?
There is give some
Initial value
initial
problem.
condition.
They give us
Only one condition. Agreed? Only one condition. See, suppose we are writing here dy by dx plus y equals to e raised to x, and they have given y of 0 equals to 4. So this is your initial value problem. So another thing is here. What is exact? Say I am starting with the exact differential equation. What is exact differential equation?
Equation of type mdx plus ndy.
See here, you are saying that is m dx plus n dy equals to 0. So this is your differential equation of first order and first degree.
We have a condition that del m by del y should be equal to del n by del x.
Yes, so this is del m upon del y equals to del n upon del x. This is your exact differential equation. Suppose here, if del m upon del y not equals to del n upon del x, so what happen?
We have to multiply it by integrating factor.
So what is integrate mean? What are the rules of the integrating factor?
Sir, it depends upon the function and our differential equation.
Yes. So and how to find solution of this equation? If it is exact, then what is the solution formula?
Integration of m
Y constant plus n terms free from x only dy equals to c. So here do one thing. I am taking a problem on integrating factor. One sec. They have given in paper, if x raised to k and x raised to h and y raised to k are integrating factor, x raised to h and y raised to k are is integrating factor of equation y into 1 plus xy dx, y into 1 plus xy dx plus x into 1 minus xy dy equals to 0. Find h and k. H and k. So what is the property of integrating factor? Means if you multiply this equation with integrating factor, then it will reduce to exact form. Yes or no?
Yes, sir.
Yes, sir.
So here, if you multiply here, so it can be written as, do one thing, open it. It can be written as y into x plus y square into x raised to h y raised to k dx plus x raised to h y raised to k x minus x square y dy equals to 0. So it can be written as x raised to h y raised to k plus 1 plus x raised to h plus 1 y raised to k plus 2. This is x raised to h plus 1 y raised to k plus minus x raised to h plus 2 and y raised to k plus 1. So please find h and k. Please find h and k. Or you can directly apply one property. Can you recall this property? If the differential equation is of the form y into f1 xy dx plus x into f2 xy dy equals to 0, then integrating factor is 1 upon mx minus ny, correct? Provided mx minus ny not equals to 0. Are you familiar with this property?
Yes, sir.
So what we can see, instead of doing all this process, we have less time, so we can directly apply here. So what we can write? M, that is y plus xy square. So mx equals to how much? Xy plus x square y square. Here n equals to x minus x square y. So ny equals to how much? Xy minus x square y square. So mx minus ny, how much? Subtract here. So how much? 2 times x square plus y square. So what should be the integrating factor? 1 upon, that is 1 upon 2 times x raised to minus 2, y raised to minus 2. So what should be the value of x and h? Sorry, h and k?
2,3.
Minus 2 and minus 2. Correct, na?
Yes, sir.
One more sum is there. One sec. Here they have given, I'm taking that paper problem only. They have given, इस theory is required. आपको theory करना है. आपको theory करना है. आपको थियरी करना है क्या?
नहीं सर.
नहीं, थियरी
Only
पे
problem, sir.
अच्छा, हाँ तो ठीक है. e raised to beta x is solution of differential equation d2y by dx2 plus dy by dx is solution of differential equation d2y by dx2 plus dy by dx minus 6y equals to 0. Minus 6y equals to 0, and they have given y0 equals to 5. Find, sorry, dy by dx, y dash 0, 5. Find y of 0. So how to solve it? You are familiar with complementary function and auxiliary equation, etc.
Yes, sir.
Yes,
So so how to solve it?
सर फर्स्ट डिफरेंशियल इक्वेशन सॉल्व करेंगे, उसके हमें रूट्स 3 एंड -3 एंड 2 मिलेगा सर. तो बीटा
Yes.
की -3 आएंगी.
बीटा की वैल्यू, हाँ.
देन हम उसका डेरिवेट करके x इज इक्वल टू 0 सब्स्टिट्यूट करेंगे.
हाँ. So everyone can get the solution. Let's see,
Yes,
this can
sir.
be written as y equals to c1 e raised to minus 3x plus c2 e raised to 2x. Or if you write into this form, so what we can see? We can see here beta equals to -3. Do one thing, once differentiate it. Once differentiated, so dy by dx equals to how much? So I'm writing here first this term. Make it c1, make it c2. So accordingly it will be how much? 2 times c1 e raised to 2x minus 3 times, and you can see here from here this is c2 e raised to minus 3x. They have given y dash 0 equals to 5. So put here, and from this observation we can say here this is c2 equals to 1. So it can be written as this is 5 equals to 2 times C1 minus 3. So here 2 times C1 equals to 8. C1 equals to 4. Basically, your answer will be y equals to 4 times e raised to 2x plus e raised to minus 3x. So now you can calculate the value of y0. Agreed? Oh, 8. Sorry. 4 plus 1. Correct. Done? Hello?
Yes, sir.
So, okay, do one thing. Can you solve this here if y equals to x into vx? X into vx is solution of differential equation x square d2y by dx2 minus 3x dy by dx plus 3y equals to 0. Plus 3y equals to 0 given v of 0 equals to 0, v of 1 equals to 1. Then v of minus 2 is how much? What is the form of this differential equation?
Cauchy-Euler's.
Cauchy-Euler. But how to solve it?
Put x is equal to e power z.
Sorry? But see, but they have given here one condition. Means you have to proceed according to this method only. See, in Cauchy's linear, so we have to again derive the result. We have to establish the relation there. So basically, what we have to do here, we have to consider y equals to vx, sorry, x into vx. So find first order derivative. dy by dx. dy by dx equals to how much? X times dv upon dx plus v. d2y by dx2 equals to how much? X times d2v upon dx2 plus 2 times dv upon dx. Agreed?
Yes, sir.
We are differentiating it again. So what we get? X d2v upon dx2 plus dv upon dx, derivative of x is 1, then dv upon dx. Now substitute all values here. Substitute here. So what we get? X square x d2v upon dx2 plus 2 times dv upon dx minus 3x x dv upon dx plus v plus 3 times v into x equals to 0. Or it can be written as x cube d, means we have to reduce it. x2 plus 2x square d2v upon dx2 minus 3x square dv upon dx minus 3vx plus 3vx equals to 0. So it can be seen here, this cancel. So x cube d2v upon dx2 equals to how much? X square dv upon dx. So it can be written as d2v upon dx2 upon dv upon dx equals to how much? How much?
X.
1 by x.
1
Or again, if you integrate it, so what we get? This is log of dv upon dx equals to how much? Log of x plus log of c1. Or this can be written as dv upon dx equals to c1x, only c1x. Again differentiate it. So this is how much? C1 x square by 2 plus C2. See, you have derived the result into V only. Now whatever they have given, you apply. What they have given? They have given V of 0 is 0, V of 1 is 1. Put here. Now, V of 0 is 0, meaning of this, put here. So C2 equals to 0. V1, 1 is 1. Put here. So what we get? 1 equals to how much? C1 by 2. So C1 equals to how much? 2. So what we get? So V equals to how much? X square. What they are asking? Agreed?
Yes, sir.
See, if you are, you can see this equation is Cauchy's-Legendre differential equation. ये Cauchy's फॉर्म का डिफरेंशियल इक्वेशन है, बट अपने को क्या मिलेगा जब Cauchy's के फॉर्म में जाएंगे तो हम क्या बोलेंगे? Z equals to log of x. So x equals to how much? E raised to z. According you have to proceed. Agreed?
Yes, sir.
Okay. Yes. So one more sum is there. If yx is the solution of initial value problem, if here yx is solution of initial value problem, d2y by dx2 plus 4 dy, I think you people can solve it, plus 4 times dy by dx plus 4y equals to 0. And they have given y0 and y dash 0. Given y0 equals to 2 and y dash 0 is 0. Find y of log 2. Please find it. What is the complementary function here? Your root solution. What will be solution?
C1 plus C2x into e raised to power minus 2x.
Minus 2x. Good. So again, they have given y0 equals to 2. So what we get? Meaning of this C1 equals to 2. Agreed?
Yes, sir.
And from here, what is y dash x? It can be written as minus 2 times C1 e raised to minus 2x plus C2 e raised to minus 2x minus 2 times C2 e raised to minus 2x. And we have already calculated the value. So here 0. So y dash 0 equals to 0 means 0 minus 2C1 plus C2 minus 2 times C2. And it is how much? 2. So this is 4 equals to C2. So C2 equals to, so y equals to 2 minus 4 times x into e raised to minus 2x. So here y of log 2. This is 2 minus 4 log 2 e raised to minus 2 log of 2. So what is the final answer? Does anyone have? Is it 1/4? Hello? Hello?
Yes, sir.
Yeah. The same answer? Or anyone have different answer? This can be written as 2 minus 4 log of 2 e raised to log of 2 raised to minus 2, and e and log will get cancelled. So 1/4, and another take this here. And log to the base e. Please remember, in calculus, all the log they have taken to the base e. Now put the value, you get the answer. So here it is, I think here so 19 paper I have taken. I have taken all the problems of 19. Agreed?
Yes, sir.
So now we can take another problem, another paper. One sec. Let me open another paper. एक सेकेंड ना. Yes. So one question is solve dy by dx minus 1 by x plus 3x square minus 1 plus 3x square into y equals to xy square, and they have given y of 1. Y is greater than 0, x0 is less than, x is less than equals to 1, and y of 1 is 3/2. So how to solve it? Can you people recognize the form? Which form of the differential equation is it?
Equation reducible to linear.
Reducible to linear. So what is the form? See, if you are saying that reducible to linear, so please see, This is dy by dx plus py equals to q. P and q are constants, are function of x only. Another form is f dash of y dy by dx plus p times f of y equals to q. This is reducible to linear. Another form, dy by dx plus py equals to qy raised to n and not equals to 0 and 1. This is Bernoulli's. So which form?
Bernoulli's form.
Bernoulli's form. So basically we have to go into reverse order. Means they have given it Bernoulli's. So we have to convert this Bernoulli's into this form, then this form, then we can write the solution. Always remember, if here other than x, in this form, if other than x and power of y is not equals to 0 and not equals to 1, so it is always Bernoulli's form. So here method is divide both sides with y square. So what we get? Y raised to minus 2 dy by dx minus 1 by x plus 3x square. Y raised to minus 1 equals to x. Agreed? It is reducible to linear form now. Sorry, yeah, reducible to linear form. So we put here y raised to minus 1 equals to v minus y raised to minus 2 dy by dx equals to dv upon dx. Or this is y raised to minus 2 dy by dx equals to minus of dv upon dx. So minus dv upon dx minus x into, sorry, 1 by x into plus 3x square into v equals to x. Or we can write here dv by dx plus 1 by x plus 3x square into v equals to x. Now it is at the linear differential equation. So what will be integrating factor?
E raised
Sir,
to power
here
b
minus x.
E raised to here minus
p
x. So e raised to p dx. So p is here this. So basically here e raised to 1 by x plus 3x square and dx. So it can be written as e raised to log of x plus x cube. And by Laff indices, agreed? Is it your integrating factor? Or want more simplification here? E raised to log of x into e raised to x cube. Then we get this. Agreed? So b into equals to minus x is into, आप लोग नोट कर रहे हो क्या?
Yes. Yes,
अच्छा
sir.
तो शायद मैं फास्ट जा रहा हूं. हाँ, तो प्लीज सी आपने केवल सारे जो स्टैंडर्ड रिजल्ट का स्टैंडर्ड टॉपिक्स है वो आपको पता होना चाहिए. बाकी न्यूमेरिकल प्रॉब्लम सब सिंपल है.
yes
This is yes. Can anyone help me here in integration? Can
we can
anyone
put
Let x cube equal to t.
Yes. Put here x cube equals to t. So 3x square dx equals to dt. So x square dx equals to 1 by 3 dt. So we can write here V means 1 upon y, x e raised to x cube. This is minus 1 by 3 e raised to x cube plus c. What they are asking? Yes, they are given this. What they are asking? One sec. Oh, solve the differential equation. Okay, okay. Only solution they are asking. So here they have given y of 1 equals to 3 by 2. Meaning of this, 2 by 3 e minus 1 by 3 e plus c. So c equals to how much? 2 by 3 plus 1 by 3 e. So c is e. So 1 by y x e raised to x cube plus e. Agreed?
Yes, sir.
Okay. One sec. Let me check. Any other problem? Yes. One sec, one sec. What I'm doing, I'm stopping this slide and sharing another thing. Are you people able to see that question paper? One sec. आपको क्वेश्चन पेपर विजिबल है? हाँ.
Yes, sir.
Please
Yes,
see
sir.
this. This question देखिए इसमें क्या है आपको? Which of the following differential equation satisfies the function? This. Yes. Can anyone say the answer? Can anyone say the answer? Here, what they have given? They have given this equation. Sorry, this value, this value. So can you people see here? What will be roots here? What are the roots?
-3 minus.
-3, -2. Please see. One thing is here. What are the roots of this equation?
-1, 2, and 3.
Yes. What about this?
1 and -2.
1 and -2. And what about this? See, in the question they are saying which of the following differential equations is satisfied by this and this. So question number one, sorry, option A is correct.
Yes, sir.
And what about the second thing? Can you see D? Solve the equation number D.
Option D.
Sorry, option D. So everyone have? Here in option D, आपने क्या करना है? आपने सीधी बात है कि अगर आपको कोई भी इक्वेशन सी, अपने को कैल्सी तो अलाउड रहता नहीं है, कैल्सी अलाउड नहीं, तो अपने को सीधी सी बात है कि जब भी कोई इक्वेशन दिया है, सपोज उन्होंने they have given this equation d cube plus 4d, see d cube plus 4d plus 2d minus 4. अब देखिए कोई भी चीज अगर यहाँ पे देखेंगे तो अगर d इक्वल्स टू 2 डाला तो क्या मिलेगा? दिस इज 8, या d इक्वल्स टू -2 डालिए तो दिस इज हाउ मच? -8 -8 -4, सॉरी ये स्क्वायर है, सॉरी माय मिस्टेक, दिस इज 16, सॉरी दिस इज 16. Okay, no problem. Okay, see here. See, factor is not possible, so random by inspection we can consider here d ka any value. So here di equals to -2. I am considering. So this is how much? -8 plus 16 -4 -4. So what we can see? Means here d equals to d -2 satisfy this. So d plus 2 is another factor. So it can be done by actual division method. 4d square plus 2d minus 4. So d plus 2 how many times? D square times. So d cube plus 2d square minus minus. So this is 2d square plus 2d minus 4. Again, please see how many times? 2d times. So 2d square plus 4d minus minus. So minus 2d minus 4. How many times? Minus 2 times. So what we get? Minus 2d minus 4. 0 is meaning of this. The factor is d plus 2 and d square plus 2d minus 2. If you do this thing perfect square here, d square plus 2d plus 1 equals to 3. So d plus 1 the whole of square equals to 3. So d plus 1 is how much? So d equals to how much? -1 plus minus or √3. So please see what will be the complete solution of this. This is C1 e raised to -2x plus e raised to -x. Oh, sorry. So, okay, hyperbolic, no need to write. No need to write into hyperbolic. You write like this only. Minus 1 plus √3x plus C3 e raised to -1 minus of √3x. So which one is the correct option? Which one is the correct option?
D part.
D part. One sec. Let me take another problem. Yes. No, we have taken this problem. Okay. Let me stop sharing. One sec. Okay. Yes. Screen is visible? Hello?
Yes,
Is
sir.
screen? No? Okay, one sec. Okay, stop. Yes. Now screen is visible?
Yes, sir.
Okay,
Yes, sir.
okay. So what about this question? The equation of the curve passing through sin y dy by dx equals to cos y in bracket 1 minus x cos of y and passing through origin. How to solve it? See, they are saying that find equation of the curve satisfying sin
Sir.
y. Sorry?
Hello, sir.
Sorry?
Your screen is not visible, sir.
Okay, one sec. Sorry. Is it visible now?
Yes, sir.
Okay. The question is find the equation of the curve satisfying sin y dy by dx. Sin y dy by dx equals to cos of y 1 minus x cos of y. And passing through the origin and passing through origin. So how to solve it? Any idea? Is it linear?
Reducible.
Reducible to linear. Okay. So please try. So what we can write? Sin y dy by dx plus x times cos square y one second. I'll do one thing, write little bit modified form. Okay. Cos of y. So it can be written as sin of y dy by dx minus cos of y x cos square of y. So dividing with cos square y. So it can be written as tan of y sec of y dy by dx minus sec of y equals to x. What next?
We can put secant y is equal
Yeah,
to
put sec y equals to v. So it can be written as sec y tan y dy by dx equals to dv upon dx. So dv upon dx minus v equals to x. Please complete it. What is integrating factor?
e raised to power minus x.
E raised to minus x. Everyone have? So it can be written as v into e raised to minus x, x into e raised to minus x, minus 1, e raised to minus x plus c. Or this can be written as v equals to minus x minus 1 plus c times e raised to x. And what is v? V equals to how much? Sec y. Sec y minus x minus 1 plus c e raised to x. Again, another thing, passing through origin. Passing through origin. Meaning of this 0, 0. Meaning of this when x equals to 0, y equals to 0. So what we can see? This is sec 0 minus 1 plus c. So sec 0 is 1. So 1 plus 1 is this. So c equals to 2. So basically this is sec y minus x minus 1 plus 2 times e raised to x. Done? Done?
Yes, sir.
One more thing is here. Solve x cube d3y by dx3. See, whenever theory part is required, please ask without any agitation. Okay? And I'm taking all the problems for from that only question paper. d3y by dx3 x d2y by dx2 minus 6 dy by dx plus 6 y by x equals to x ln x x log of x plus upon x square. Find the general solution. Please find it. Please find it. वो यहाँ पे नहीं, बाद में बेटा बेटा इंपॉर्टेंट लेक्चर चल रहा है, इंपॉर्टेंट लेक्चर चल रहा है, थोड़ी देर में देता हूँ मैं आपको. Which form is it? Which form is it?
Cauchy-Euler.
Cauchy-Euler. So what is the form? See, this is Cauchy-Euler's differential equation. Means this is x raised to n dny upon dxn plus x raised to n minus 1. You can take p1 n minus 1 dy by this p2 x raised to n. This is x raised to n minus 2 dn minus 2i upon dxn minus 2 plus dot 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 p and y equals to capital X, where p1, p2, p3 dot 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 pn are constants and capital X is function of x only. Capital X is function of x only. And how to solve it? To solve, put here z equals to log of x, which implies x equals to e raised to z. Then x dy by dx equals to x square d2y by dx2 equals to how much? d2y by dz2 minus dy by dz, and x cube d3y by dx3 equals to how much? d3y by dz3 minus 3 times d2y by dz2 plus 2 times dy by dz. Agreed? So this is the theoretical approach. Putting all these values, given equation, reduced to linear differential equation with constant coefficients. Agreed? Yes, should I solve it? Should I solve this differential equation?
No, sir.
See, here x is missing. So first of all, we have to multiply throughout by this x on both sides. So it will reduce to standard form. See, when completed, please confirm. Done. Previous one.
Yes, sir.
So please. Already you people told that this is exact means. Exact means.
Del M by del Y is equals to del
Yeah,
M by del
please.
X.
This is your M and this is your N. Please find the derivative, partial derivative. And compare it. Done. What is the value?
C is to
Value
B
of
is 4.
C equal to 4. C equal to
Sorry.
B equal to 4.
Equal to 4, C equal to 4.
C equal
D by n upon D by x. This is 4x plus cy. Yes, C equals to 2, B equals to 4. And what about A?
Any
A can be
value.
anything.
Sorry?
Any real number.
anything, sir.
Any real number. Okay. Okay, let me take another question. Are you people familiar with method of variation of parameter?
Sir.
Huh?
No, sir.
No. Okay. See, in higher order differential equation, there are especially two things. See, we have differential equation. Suppose d2y by dx2 plus p dy by dx plus qy equals to r, correct? This is a second order differential equation where p and q are constants, correct? So how to solve it? First of all, we use to define auxiliary equation. Yes or no?
Yes, sir.
So here on the basis, suppose roots are here alpha and beta. So what we people use, y1, so we can write here y equals to c1 y1 plus c2 y2. See, your solution will be how much? Complementary function, or you can say here c1 e raised to alpha x plus c2 e raised to beta x. And this is alpha x and beta x are nothing but y1 and y2. So it can be written as yes or no?
Yes, sir.
Now,
Yes, sir.
you are familiar with the method of particular integral. Method of pi. pi क्या होता है भाई? 1 upon f of t into capital X. So what are the possibilities? What are the possibilities? Case number 1, capital X is exponential function, means e raised to ax, e raised to minus ax, a raised to x, etc. So here a raised to x means, if you see, sorry, if you recall this, so 1 upon f of d e raised to ax. So what is the rule? 1 upon f of a e raised to ax, that is replace each d with a, provided f of plus minus a not equals to 0. Agreed?
Yes, sir.
Here if, one sec, if f of a equals to 0, then what happen?
We take its derivative.
Yeah, so f of d e raised to ax, I'm taking plus minus together, so x upon derivative of denominator with respect to d, later we have to put here d equals to plus minus of a. This is one case. Number 2, if here e raised to x, so what, sorry, a raised to x, so what we have to write? Agreed?
Agreed.
See, because your formula is for e to the base e. If it is base a or anything, then we have to convert into e raised to ax. See, second rule states, if capital X is, sorry, trigonometric, you can say polynomial or trigonometric function, that is sin ax and cos of ax. So what is the rule?
D square equal to minus s.
D square equals to
Minus s.
minus of a square. Here 1 upon f of d square. I'm coming to that point, method of variation of parameter. Just wanted to inform you that why it is required. See, when we can solve the problem by general method, then why method of variation of parameter or undetermined coefficients are required? So replace each d square with minus of a square. Way of writing, please see. Provided f of minus a square not equals to 0. Now, in similar manner, if f of minus a square equals to 0, so again it can be written as 1 upon f of d square sine of ax, which can be written as x upon f dash of d square. Now here replace d square with minus a square. If any, if anything left, then we have to apply it. Agreed? And so on. So my next question is, how to simplify this value? If we have somewhere like this,
So we write for x upon 2a into sin a.
sorry,
Its answer is x upon 2a into sin a.
okay. This is you have to multiply and divide with d minus a. See, you have to remember that we have to apply, we can apply the formula when there is d square only. So means you have to reduce d square and generate d square here. That's why we have to multiply and divide. Later on we can apply. So this is another thing. Third case is, if capital X equals to x raised to m, this is algebraic polynomial, 1 upon f of d into x raised to m. So what we have to do? We can take a lambda term common, whatever the constant term common outside, and this way. Or it can be written as 1 upon lambda minus 1 into x raised to m. And most probably everyone knows this formula. 1 plus x raised to minus 1, how much? And so on. 1 minus x the whole of square, 1 plus x square plus and so on. We will expand this term using either this or this formula and simplify it. So basically we have taken algebraic, trigonometric and exponential. Another cases may arise, that is product of any two. So further we have to apply. For example, if they have taken, suppose they have taken f of d into e raised to x. So what we have to do? What we have to do?
Put d, replace d by d plus a.
Yes, very good. So we have to write here e raised this f of d plus a into v. Later, if v is trigonometric function, apply rule number 2. If here v is algebraic function, apply rule number 3. Another thing, 1 upon f of d x raised to m into v. So again, suppose here where v is, one sec, where v is trigonometric function. So most probably everyone familiar with this formula, sin ax, or that is Euler's formula, e raised to iax minus of e raised to minus iax upon 2i. This is cos of ax, e raised to ax plus e raised to minus iax upon 2. Are you people familiar?
Yes, sir.
So if you substitute in place of v in place of v, if you substitute, so what we get? E raised to iax. I am taking here cosine term first, upon 2 into v. So one can write here 1 by 2 outside. 1 upon f of d e raised to iax into v plus 1 upon f of d e raised to minus iax into v. Can you see the previous form here? Yes or no?
Yes, sir.
So now next type C. Now next question I'm writing here. So here if, first let me write the question. Let y equals to ux sin x plus bx cos x be the solution of differential equation y double dash plus y equals to sec x. Find then find ux. Yeah, let's see. We have written 5, 6 forms. Is there, we are getting sec ax, tan ax, sec square ax, etc. in any form?
No, sir.
No, sir.
No. So in such type of problem, when right hand side does not belongs to the standard result or standard formulas, then we have to apply method of variation of parameter. Okay.
Yes, sir.
Okay. So here now, actually, let me. Okay. So, please recall this. Please recall this equation. One sec. So I think everyone can recall this. So now, if they are saying that this we have right hand side to this form, so method of variation of parameter, say in method of variation of parameter, particular integral pi is given by ui1 plus vy2. Please see, they are given into that form only. Can you see? ui1 plus vy2. Another thing, we have u and v are unknown. So formula is here y2 capital X upon w dx and v equals to y1 capital X upon w dx. Now w equals to, are you familiar with this notation?
Yes, sir. It's Ronskine.
Raskines. Okay. So here we have to calculate this value w and then we have to go for the remaining result. Okay. So see, here they have given differential equation y double dash plus y equals to sec x, or we can write here d square plus 1 into y equals to sec x. So what will be our auxiliary equation? D square plus 1 equals to 0. So d equals to plus minus I. So complementary function is c1 cos x plus c2 sin x. Agreed?
Yes, sir.
This is the standard result. Now, if you apply method of variation of parameter, so pi can be written as uy1 plus vy2. Here y1 is cos x, y2 is sin x, and capital X is, okay, sorry. So u equals to minus y2 capital X upon w, v equals to y1 capital X upon w, and w equals to, can I directly put the value? Cos x sin x minus sin x plus cos x. What is Wronskian's?
1.
1. So please calculate u and v. Now please calculate u and v.
U is equal to log sec x.
Log of sec x. And what is v? See, in our
X.
question, yes, in our question we have changed the values u and v ka, we have changed the position of u and v. So in question they have given let y equals to y x equals to u sin x plus v cos x be the solution of given differential equation. Then ux is ln cos x minus x plus c x plus c ln sec x plus c. So what will be our answer?
X.
X plus c. See in section 1, in section 1 they have given one question. So method of variation of parameter is clear. Are you people want more sum on that topic?
Yes, sir.
One more sum or that is sufficient one problem?
One more,
Sir.
sir.
Sorry? Sufficient?
Yes, sir.
Okay. So here I'm writing another sum. Here if integral curve if integral curve of the differential equation y minus x dy by dx equals to 1 passing through 0 0 एक second here passes through 0 0 and alpha 1 and alpha 1. Find alpha, please. You people are solving it?
Yes, sir.
Okay. Is everyone have written into this form? Everyone have written the differential equation into this form?
Yes, sir.
Or any
Yes.
other method? See, always remember, whenever degree of x and y throughout is 1, then try to solve it by linear method only. So in linear method, we have two forms. If y is dependent variable, so we have dy by dx plus py equals to q. And if x is dependent variable, so dx upon dy plus px equals to q. And here p and q are function of y only, are constants. Here p and q are function of x only, are constant. So what is integrating factor here? Agreed?
Yes, sir.
So here if equals to e raised to p dx, and here if is e raised to p dy. Use the successive integration formula. X into e raised to y e raised to y minus e raised to y plus c, or x equals to okay, y minus 1 plus c times e raised to minus y. See, further they have given x is 0, y is 0. So this is 0 passing through origin. Okay. Okay, alpha. Passing through this origin. So 0 minus 1 plus c into e raised to minus 0. So what we are getting? C equals to 1. So x equals to y minus 1 plus e raised to minus y. Here alpha. So 1 minus 1 plus e raised to minus 1. What is the value of alpha?
1 by e.
Yeah, e raised to
1
minus
by
1. Sorry?
1 by
Yes. So please, can you try this one? Yeah, please solve it. I'm coming. Yes, you got the solution.
1 by y square.
1 by y square. What about other people? So how you have calculated it? Huh?
Sir, by cross multiplying it and dx into something minus dy into something, then let x ke power h y ke power k, then compute.
Yes, yes, yes. Okay. Everyone have? Huh? Or anyone? Okay. So your next sum is if white is solution of yt is solution of differential equation y double dash plus 4y equals to e raised to t then find limit t tends to infinity e raised to minus t yt, please. Please find it.
0.2.
Okay. Let me check. Sorry, what option they have given? 1 second.
0.4, sir.
Okay. 0.4. No. They have option 2 by 3, 2 by 5, 2 by 7, 2 by 9.
2 by 5.
2 by 5.
2 by 5.
Yes. Should I solve?
No.
What about other people? See, this is d square plus 4 equals to 0. D equals to how much? Plus minus of 2i. Correct, na? So your complementary function will be c1 cos of 2x plus, sorry, they have taken t. So c1, c2 sine of 2t. Now what about pi? 1 upon d square plus 4 into 2 times e raised to t. So 2 times e raised to t by 5. So y equals to c1 cos of 2t plus c2 sine of 2t plus 2 times e raised to t by 5. Correct? So here limit t tends to infinity e raised to minus t into it. So here e raised to minus t c1 cos of 2t plus c2 sine of 2t plus do one thing, I will close this bracket and I will write here 2 by 5 separately. Correct, na? So it is 2 by 5.
Yes, sir.
And what about other people? No one is answering.
Yes, sir.
Yes, sir, 2 by 5.
One sec. Let me take another sum. We have one problem, the initial value problem. The initial value problem dy by dt equals to root of y y0 equals to alpha. Alpha is greater. At least two solutions for alpha is greater. Number two, no solution if alpha is greater than 0. No solution if alpha is greater than 0. Number three, at least one solution if alpha is greater than 0. And number four, unique solution if alpha equals to 0. So what will be the correct answer? Huh?
Third one.
At least one solution.
Yes, sir.
So how you have derived? dy dt, correct na?
Yes, sir.
dy equals to dt plus c. So y raised to 1 by 2 into 2. This is t plus c. And they have given t equals to 0. They have given t equals to 0. So y of 0 is alpha. So here 2 times root of alpha equals to c. Yes, because alpha is a variable, na? So alpha at least. That's why they are saying that at least. Agreed, na?
Yes, sir.
Okay, okay. So, what about orthogonal trajectory? How to define orthogonal trajectory?
Sir, a curve which cuts the every member of family of curves at the right angle.
Right angle. And how to derive it?
Sir, in Cartesian form, differentiate the given equation with respect to x, then to eliminate parameter, and then replace dy by dx into minus dx upon dy.
Okay,
And
okay. Okay, so I'm taking a question based on that orthogonal trajectory, because this is again the part of differential equation only. One sec. Then this is done. Okay, so very simple question. Find orthogonal trajectory of orthogonal trajectories of y equals to c1 x cube. So a theory part I'm going to explain first. Just you suggested that, sir, orthogonal trajectory means 2 of u equals to c1 and u equals to c2 are said to be orthogonal to each other if they intersect at right angle. Can you recall that two perpendicular lines? When two lines are perpendicular, so what is the relation between slopes?
m1 m2 equal to -1.
Yes, m1 into m2, second line, a second curve. So here, if they have given y equals to f of x, First step, find dy by dx. This is your f dash x. Now substitute, yeah, eliminate. You can say eliminate constants and put dy by dx equals to, agreed? Agreed?
Yes, sir.
Yes. So I think you have answer of this.
Yes, sir. It's 3y square plus x square equals to 1.
Yes.
मतलब constant.
Constant, yeah. Anyone else? This is dy by dx. This is 3 times c1 x square. So please see here, from here, what is the c1 ka value? Y upon x cube. Therefore, dy by dx equals to 3 times y by x square. Sorry, x cube. Sorry, my mistake. Into x cube, x square. So what we get? Dy by dx equals to 3y by x. And here, the same thing. We have to write here dx upon dy equals to 3y upon x. Or one can say here minus x dx equals to 3y dy. Or this is x dx plus 3y dy equals to 0. Integrate it. X square by 2, 3 by 2y square equals to c. Or this is x square plus 3y square equals to c, correct? The same thing you have?
Yes, sir.
Yeah. So another thing I am taking, find orthogonal trajectory of x raised to 2 by 3 plus y raised to 2 by 3 equals to a raised to 2 by 3. Please try it. Please try it. Should I solve it?
Sir, x raised to the power 4 by 3 plus minus y raised to the power 4 by 3 equal to constant.
Yes. What about other people?
Yes, sir. Same answer.
Okay. So one sec. Let me check in question paper if there is problem based on this. So we can solve it. See, actually, I am trying to cover all the previous year's questions because you people have sufficient knowledge of theoretical approach part. So no need to discuss all those things. In next session, we will take another type of problem because once we have sufficient knowledge of these things, so we can easily go for the little bit theoretical problems. y1x and y3x, okay, छोड़ देता हूँ ये. One sec. Suppose we have one sum. I'm writing here from my side. Most probably dy by dx plus mod of y equals to 0. Mod of y equals to 0. And they have given y0 equals to 1. Can you people solve it? Sir, what are the possibilities here?
Sir, no solution.
No solution. Why?
Because when we take y is equal to something, then it's not satisfy the initial condition.
Initial condition. If you have y equals to 0, then?
Then y equal to 0 is the unique solution.
Yes, solution. So you have to write like this, okay? Okay?
Yes, sir.
You are familiar with the Lipschitz conditions also?
Yes.
Lipschitz condition?
Yes,
No,
sir.
sir.
Huh? Yes or no?
Yes, sir.
Okay, so see, we have taken one sum there. So similar problem, type of problem I'm taking here. Root of mod of y. Y of 0 equals to 0. What is Lipschitz condition? What is Lipschitz condition?
Sir, first one is the modulus of f of x2 minus f of x1 is less than equals to Lipschitz
Any
constant
constant.
into x2 minus
Yes.
mod of.
Yes.
And another one is the derivative of f with respect to y is less than equals to some k.
So what we can say about this? The question is like this: prove that continuity is of f of xy is not enough to guarantee the uniqueness of the solution. Question is like that: prove that continuity. See, आपने बोला, so you are saying that a differentiable function. Lipschitz condition means dy upon dy by dy upon dy that thing. इसका मतलब we are saying that function is continuous also. So here question is prove that continuity of f of x comma y is not enough to guarantee the uniqueness of the solution of initial value problem. This. So how to approach? How to approach it? See, here we consider f of xy equals to root of mod of y. This function is continuous everywhere. Yes or no?
Yes, sir.
This is continuous everywhere. So here, what are the possibilities? This is, if you consider here dy by dx equals to one thing is minus of root of y, because your modulus function is defined like that, na? Mod of x is how much? This is plus x for x is greater than 0. 0 for x equals to 0. And this is minus x for x is less than 0.
Yes, sir.
It can be written as dy by dx, the whole of square equals to y. Or we can say here, this is minus y for y is less than 0, 0 for y equals to 0, and this is plus y for y is greater than 0. If you simplify it, so we get here y equals to x square by 4. For x is greater than 0, 0 for x equals to 0, and this is minus x square by 4 for x is less than 0. Another thing, if you recall that condition, day by f upon day by y. So this denominator, the derivative will come into denominator, so it is already undefined. Clear? Okay. What about that polar form, orthogonal function in polar form? Orthogonal trajectory in polar form. Hello?
Yes, sir.
What is orthogonal trajectory in polar form? Any idea how to derive or how to solve?
Yes, sir.
So suppose we have one thing, find orthogonal trajectory of family of curve r equals to a1 minus cos theta. Please find it.
Yes, sir.
Can you explain the steps here? Can you explain the steps?
Yes, sir. First we differentiate it with respect to theta, then eliminate the parameter, then replace the dr by d theta equals to minus k r square d theta upon dr, and then solve
Yeah,
no differential equation.
Okay. What about other people? What about other people? So we have to start at 1, na? Stop at 1, na?
Yes, sir.
Okay. So the okay, so we will start and stop here and we will meet again at 2. Okay?
Thank you, Arvind sir.
Yeah.
So the break will be from 1 p.m. to 2 p.m. and
Okay,
the
sir.
next session will begin at 2 p.m.
Okay.
So candidate and all those students, please keep this thing in mind. So let us meet at 2 p.m. Thank you.